For these examples, we are going to look at the topics of simplifying radical expressions. So looking at the problem on the left first, we have negative cube root of w cubed divided by 125. So remember, the properties of radicals tells us that we can give that radical to each the numerator and the denominator. So we have negative cube root of w cubed over cube root of 125. Okay. On the numerator, since our exponent matches our index, we know they cancel. So that means we are left with just a negative w on the top. So I went ahead and attached that negative to the numerator. On the bottom, since we have the cube root of a number, we're going to have to do the prime factor tree to see if we could simplify this radical. So we know 2 doesn't go into 125. So let's check 3. 3 doesn't, so I think 5 goes into 125 25 times, and then 5 goes into 25 5 times. Since this is a cube root, we do pairs of 3. Since there's only one pair of 3, that tells us our answer is going to be 5. So that means we have the simplified expression of negative w over 5. We're going to apply that same concept to the second example over here, where we have the 8th root of u to the 8th and v to the 24th. So just like I gave the root, that radical, to both the numerator and the denominator, I'm going to give it to every term under this radical. So I could rewrite this as the 8th root of u to the 8th and the 8th root of v to the 24th power. On the u, we see that our index matches our exponent, so that tells us that it cancels. So far we have u. Looking at our other radical, we have the 8th root of v to the 24. So we could do this two ways. We could write v 24 times and circle pairs of 8, or we could say, how many times can 8 go into 24? Well, 8 actually goes into 24 exactly 3 times with nothing left over. So if it goes in 3 times with nothing left over, that means our radical is gone and we are left with 3 v's that we write v cubed. So this would be our answer, u times v cubed.